Now, if we want to find a confidence interval for differences between means, this is a little bit different. Now, why would we do this? Well, let's say we're trying to compare two samples to see if the point estimate means are different. Well, in this case, we have two graphs here. We have a class A and class B. And we see that here's our confidence interval for class A, and here's our confidence interval for class B. And we know that the population parameter is going to have to sit between the confidence intervals. So if they overlap, then the population parameter is probably going to sit in that overlapping section. And we could see that between class A and class B. If they're from the same population, that's going to be true. But if they're from different populations, then that won't be true, and they will have different population parameters. And this is what tells us that the two samples probably come from different populations because their confidence intervals don't overlap. And this is what we're looking at when we're looking at the confidence interval for differences between means. And we'll get a little bit more in detail when we do tests for means. So here's what we look at it when we see the formula. It's pretty much similar to the other ones that we had. In this case, we have the first part, which is x1 bar minus x2 bar. So that's the sample mean of the first sample and the sample mean of the second sample. We do our plus minus, the t multiple, which we've known how to calculate, and we multiply that by the standard error of x1 bar minus x2 bar. Now this is a little bit different because the standard error x1 bar minus x2 bar is actually going to be the pooled estimate of the standard deviation times the square root of 1 over n1 plus 1 over n2. We have to combine the standard errors of both of the samples, and so it's done by a two-step formula. So we see here we have this SP, which is the pooled standard estimate, and it's a little bit of a long equation, so it's the square root of n1 minus 1, so the number of observations in sample 1 minus 1, times the square of the sample standard deviation, which is really the variance of the first sample, plus n2 minus 1, so the number of observations in sample 2 minus 1, times, again, the variance of the sample 2. And we divide that by the total number of observations, which is n1 plus n2, and we subtract 2. It's similar to the other one, and knowing the formula isn't as important as to why in an introductory statistics course, but would be a little bit later on. So let's take a look at an example here. On the right, we have 28 sample salaries, 20 are shown. The pink box shows the Excel calculations that were done for each of the samples, N1 and N2, Department A, Department B. And we calculate each mean, which is X bar, X1 bar, and X2 bar, and their differences, which is X1 bar 1 minus X bar 2. Now, from the previous slide, we saw that the confidence interval was given by X1 bar minus X2 bar, plus or minus the t multiple, times the standard error of the difference itself. The t multiple is now calculated with n minus 2 degrees of freedom and a 95% confidence interval. So we're going to use, again, the equals t dot inv to give us the area under the curve of a t distribution. We do the dot 2t for the two-tail, and we do 0.05 because we want 0.05 of the curve underneath those two tails. And so it's going to be comma 54 for the degrees of freedom. So there's a total of 56 observations, but now we're doing n minus 2 degrees of freedom, and that's because it's n minus 1 in each of the samples. So we're holding one for the first sample, we're holding another for the second sample, and that's why we're doing n minus 2. It's because of the number of samples. Our mean difference was calculated as x1 bar minus x2 bar, which is 8827. Our pooled standard estimate was now calculated as 32786. So therefore, the standard error of the difference is given by the following formula, which turns out to be 8762.57. Therefore, our confidence interval between the means is the 8827 plus or minus 2.005, which was calculated as the t multiple, plus, times 8763, which we rounded, which equals 8827 plus or minus 17.568. So our confidence interval for the difference between the means is negative 8740 and 26935. So you're going to notice that that span covers 0. In other words, it goes across 0. And so what that means is that the difference between the two means has a possibility of being 0. If the confidence interval did not cross the 0, it means that the two means, or the two samples, will be different from each other. And we'll see this in a little bit more detail in one of the future chapters.